Hi, this is Will Pincek, and this is going to be a learning byte on Contrail Enterprise Multicloud. And I'll be showing you how to do virtual machine to bare metal server bridging. So what is the VM to BMS bridging use case? So the idea is we want to establish layer 2 communication between a virtual machine and a bare metal server over an EVPN VXLAN overlay network. And what Contrail Enterprise Multicloud is going to do for you is going to automatically configure the VXLAN Layer 2 gateway function of the Tor switch, which if any of you have configured EVPN VXLAN on a QFX switch, you know that that's probably the hardest part of the whole thing. So Contrail Enterprise Multicloud will do that for you. So here's our topology. This blue area over here is the logical thing we want to create here. We're going to create a virtual machine, which will just be an OpenStack VM on a compute node. And then we will have a bare metal server here that will attach to the same virtual overlay network. Okay, and this so it's virtual network A. Call it virtual network A, but it's really a subnet of 192.168.1.0. This is our objective, and we want the VM and the bare metal server to communicate. But physically, and I guess logically, this is what the reality is, okay? Which is we have an IP fabric here, has a spine of a QFX 10K, has two leaf nodes of QFX 5100s. There will be a bare metal server hanging off of this Gigi 004 interface of QFX 5102. Okay, that's where our bare metal server will lie. We also have a Contrail Enterprise Multicloud installed, so we have Contrail networking installed over here. We've got a compute node that houses a virtual router, and attached to that virtual router, we're going to launch a virtual machine using OpenStack. And then once we launch this bare metal server instance, Contrail Enterprise Multicloud will go in, automatically configure this bridge domain for you, and provide the overlay VXLAN tunnel, allow for the VXLAN tunnels to be created using EVPN signaling. And that's essentially what we're going for. We see here that when we get into Contrail Enterprise Multicloud, the spine nodes will have to be given a role to perform. In our case, we at the very minimum need the QFX10K to support the CRB gateway role, which is it's called Central Routing and Bridging Gateway role, which is the ability to do the routing between overlay network in the spine. Okay, that's what the C is for central, so it's centrally located routing. In this case, we're not doing no routing, so although the QFX10K won't be doing any central routing, we still have to make sure that it has that role assigned when we onboard this IP fabric. And then the two QFX10Ks will perform the central routing bridging access role, which is where it's going to do the VXLAN layer 2 gateway function. So that's essentially what we're going to do. Let's see, what are the prerequisites for this? So number one, there must be an existing Contrail cluster that has the Contrail Command user interface in place. Okay, I've got a learning byte on how to do this, or I'm going to have a learning byte on how to bring up a Contrail cluster. And then VXLAN routing must be enabled, and we'll verify that. And we need to have an onboarded IP fabric with EVPN VXLAN overlay signaling established. The spine nodes need to have at the very least the CRB gateway role, and the leaf nodes need to have the CRB access role assigned. And this, we're not going to go over the onboarding of an IP fabric. I've got a separate learning byte on that for both the brownfield and greenfield use case, so go look to those. So we're going to assume that all this is in place, and we'll verify it, but we won't show you how to do that here in the next few steps. So because we have an existing onboarded IP fabric, okay, here's our IP fabric as before. Here's our Contrail Enterprise Multicloud cluster that's already been laid down. We've got an OpenStack node, so an OpenStack orchestrator. We've got the Contrail control node that also does the config and analytics portion. We've got two compute nodes that are hanging off of two different leaf nodes here. but we've got compute 1 that has the V router, compute 2 that also has the V router and is also an OpenStack compute node, and then there's the Contrail service node, which will provide DNS and DHCP services for our bare metal server. And then also worth noting here is that we have multi-protocol IBGP sessions already established. This is part of the onboarding process, is that Contrail Enterprise Multicloud will go out, and once you onboard these devices, Contrail Enterprise Multicloud goes out and automatically configures the EVPN sessions between the control node and all of the fabric nodes, so that eventually they can build EVPN VXLAN tunnels over them. Okay, so that's existing. So what we're going to do is we're going to verify a few things. So here over on the left, I've got the list of steps we're going to go through to make this happen. Okay, so we remember our topology. We have one VM and a bare metal server out there. I'm just going to bring this back up just so we can see that here's the topology we're going for is here. Bare metal server off of Gigi 004 on QFX 5100, and we're also going to launch a VM on the compute node. So that's our goal, and we're going to be able to bridge between them, so they'll be able to communicate over this subnet here, which is 192.168.1.0. That's our goal. So first off, we need to see that we have a let's get to here, that we have a cluster already. Okay, it's established. Okay, it's already been built out. We have a control node, like I showed you in the diagram. We've got 2 compute nodes. We have a Contrail service node. Okay, we're not going to have any bare metal servers, but that's it. That's what we have. We can see that there. Now I want to go and see our fabrics. Here we have a fabric called Brownfield. I called it Brownfield because I did a onboarding of the Brownfield IP fabric. It's got three devices. I've got a spine device. Now, if I hover over here, I can see the roles that have been assigned. So it's a route reflector, which is now required in 5.0.2 for there to be at least one route reflector. It's also performing the DC gateway role and the CRB gateway role, which is perfectly fine. I only really need the route reflector and CRB gateway role to be there. So that's already there. And again, we don't show you how to do this to onboard this fabric. That's done in another learning byte. I've got 2 QFX 5100s, and they're doing the CRB access role. Okay. So that takes care of verifying the roles of the fabric devices. I've missed this one, verifying MP BGP. So I'm going to go to the 10K. And if you remember, diagram here, we have this. We should have 1, 2, 3 EVPN BGP sessions to each of these devices. And notice that the IP address of the Contrail control node is 10.10.20.3. So just keep that in mind as I go and look at this 10K. If I say show BGP summary, sure enough, I've got my underlay BGP sessions are established. Okay, because my underlay is based on eBGP. But then I have 3 iBGP sessions for EVPN signaling. Okay, that are established. I've got one to both leaf nodes, and then I also have one to the Contrail control node. And remember, this is the QFX 10K we're looking at. So this is good enough for me. I've got EVPN sessions established. So let's go back and see what's next on our list. So we've looked at our MP BGP sessions. Those get established during the onboarding of the IP fabric. Also, the CRB roles have been assigned. We did that during the onboarding. I want to verify VXLAN routing. Not quite so necessary to have this in this bridging role. If I wanted to be able to do routing between overlay networks or being able to route to the internet, I would need to turn this on. I'm going to go ahead and show you where to turn that on. I'm going to see that under projects. Under admin, it's here that you need to have VXLAN routing enabled, which I already do. Okay. Then I need to verify that the CSN has been assigned to the CRB access devices. So remember, if I look at our diagram, we want this bare metal server to be able to get its IP address from DHCP. Well, who's going to be the DHCP server? That's the CSN's job, okay? Because the compute, well, that's its job, is to provide those services, DHCP and DNS, for any bare metal servers. Now, in order for this BMS to have the ability to reach it, we need to assign the CSN to the leaf nodes that may have bare metal servers assigned to them. So it turns out I have not done that yet. So let's go then to our fabric. So we go to our fabric and we see here our QFX 5100 1 and 2. We know we want it on 2, so I'm going to go and edit QFX 5100 2. And it's down here where you will associate a service node. Okay, so I'll associate a top of rack service node. Okay, it should be a Contrail service node, but it still says Tor service node. And here we'll select from our list of possible ones. So we only have one in our topology, so we'll say save. Okay, so now if we ever decide that we want to attach a bare metal server to QFX 5101, well, we'll have a CSN that will be able to provide the DHCP and DNS servers to those services to those bare metal servers. So I'm also going to do it to QFX 5101 because who knows, someday in the future I may want to attach a bare metal server to it. In this case, but in our topology, there is no bare metal server being attached to QFX 5100. You'd see another blue box over here, so we don't have to worry about it. But I just assigned it. So now that's done. So let's bring up our list. So I've now verified that. Okay. Then I want to modify the default security group as well, because to allow traffic in and out of our VMs, bare metal servers, we want to make sure our security group's set up to allow that, because by default, each of those, the bare metal server and the VM, will be assigned to the default security group. So we'll need to modify that to make sure we allow traffic in and out of those devices. And by default, they won't, and that's because they're matching on security group. We need to modify that. So here for ingress, egress, we're good because we're matching on everything out, IPv4 and IPv6, which we see here. But for ingress traffic, unfortunately, we're not allowing anything. So what we need to do is change this to CIDR and make sure that this is set to the default route, the default address here, which is what we have here. That's for IPv4. For IPv6, we have a separate one. Also change it to CIDR, and it also happens to put in the exact address we want, which is the default address. So now, if we hit save, we'll now allow all traffic in to these devices. So no traffic will be blocked. So we'll be good. Okay, so that's that step. Okay. Now that we've done all that, we need to create our virtual network. Again, we're going to create virtual network A using with this subnet addressing. Okay. So we're going to create our virtual network. We'll do that here on the Contrail Command user interface. We create our virtual network, specify create, give it a name. I'm going to give it a name of virtual network A. I'm going to add a subnet. Okay, I'm going to select the default IPAM. I want to use this subnet. Like I said, it's just like our diagram. I'm going to specify an address pool to divvy out addresses from, so 100 to 110. I only need 2, but there you go. A gateway that'll go along with our DHCP. It'll be this the router address that gets sent out in DHCP, and then the service address, and this is the address, the logical address of the CSN on that subnet. Okay, and we're going to provide DHCP and DNS services for our bare metal servers and for our VM. So here we say create. So that gives us our virtual network. Now I want to launch that virtual machine. So I go over here, go to instances. There I create our virtual machine. So here's server type virtual machine. I'm going to give it a name of VM1, just like our diagram. I'm going to boot from an image. I've got an image pre-installed. I've got a flavor pre-set up. I'm going to attach it to VNA. Okay, and notice that it gets associated with the default security group. So I'm going to specify the Nova zone, availability zone. I'm going to only build one VM, and I'm going to say create. And sure enough, that's going to instantiate a VM hopefully on compute 1. It doesn't really matter but which compute node it goes on, but in our diagram it shows compute 1. So we hope that that comes up. Hopefully it comes up. And then from there, we're going to launch it. We launched our VM. Now we're going to create the bare metal server. Now, what this does is it's going to logically associate its interface with a interface of the top of rack switch that we're going to attach to, which will be Gigi 004 of QFX 5102, and we'll need to specify the MAC address of that bare metal server. So you'll need to know ahead of time the exact MAC address of the bare metal server. Okay, so let's go here, and we're going to go under Servers,